Okay, so it's now time for a short look at logical operators and a couple of things around logical operators just so we are on the right track to understanding how they work. So the first thing that we're going to do is just basically look at what the operators actually are, and these are and, or not. So we have three logical operators. And looks like this, it's two ampersands. Or looks like this, it's two pipes, so two vertical pipes, and not is not. Now we've already seen this in things like not equals, but we can use not for things like not true, things like that, which is false, not false is true. So we can do things like that too. Now the first thing to really talk about is short circuit evaluation, which means that with logical expressions they're evaluated, or however you want to explain it, left to right. So if I was to say true, that comes as true. If I was to say false, that comes as false. If I was to say true and false, because it's evaluated left to right, true is now taken as the sort of the short circuit evaluation. So it will always be with false and true, it'll always be evaluated to false. So false and then anything else is always false. But with true, if it's true or something else, so even if it's true or false, that's always true. So that's just good to remember in terms of the logic when you're writing an if statement. But let's take a look at some actual real uses for this. So for example, we have the variables name that we created in the last video, and we have the variables age. So we could say something like name is equal to Alex and age is equal to 24. We know that that's true. We've used an and logical operator to say that we want them both to be true. If, for example, this says 26, this comes back as false because name is equal to Alex, but age isn't equal to 26, and therefore this is evaluated to false, because what we have here is we have a true and a false. If we were to turn this around and say age equals 26 or name equals Alex, this is true because we have a false or true, so we get true back. It's always going to evaluate to true. If we have again this something like name equals Alex or age equals 26, this comes back as true because remember true, which is this side of the operation, so the left hand side of the operation, or this being false is true because we've got a true value to start with. Now what we can also do is we can also put things in parentheses, so we can say something like if we had another variable, for example, so let's just say available today equals false. So we now have the variables. Let's just open up our browser, name, age, and available today, which is a Boolean. What we could do is we could say if name is Alex and age is 24, put that in brackets and available today. That's false because what's happened here is we have this evaluating to true. So if we were to just take this on its own, evaluates to true, but we now say if that's true and this is true, I haven't actually put equal to false or equal to true. Don't need to do that because it's a Boolean value. It will automatically tell me or detect that it needs to be true or false based on that value on its own. So we could just say available today. We don't need to say equal true or equal false or anything like that. But basically that's how it works. So we're looking at the short circuit evaluation, left to right evaluation of these, and we looked at logical and logical or and logical. Well, we haven't looked at logical not, but it sort of makes sense. we'll swiftly move on to logical not, because I think this makes sense to most people if you've done some kind of programming before. Let's just say I'm going to say if name, in fact, let's clear this. If name equals Alex and not available today. Now this is going to evaluate to true because my name is Alex and I'm not available today. So we're saying if you read this as not, it makes a lot more sense. So name equals Alex and not available today, that's true. If I was to go ahead and change this value to true, using the same, let's pop back to the console, using the same, it's false because I am available today. So my name is Alex and not available today, well I am, so this evaluates to false. So equally I could remove the not and that would just be true. So that's logical operators, and hopefully the understanding of the left-right evaluation helps. But really when you are creating if statements and you're using logical operators, it just makes sense to read it as you would a sentence and actually look at it and read it out, make sure it makes sense, and then the sort of logic around it will make more sense if it reads more like a sentence. So when you are programming, it's a good idea to either scribble it down or just do it in on a bit of paper or on the computer, just basically to work out the logic of the way that you need to do things. That way you can use parentheses to group things together if required, and it just makes the logic first of all work, and then second of all just look and read a little bit better if things are separated out.